Alrighty, it looks like incoming traffic is starting to slow down. Welcome everybody to Pottorff's Webinar Wednesday. I'm Kelsey Flickinger, the Marketing Associate here at Pottorff. I'll be hosting the webinar. Today, our Damper Product Manager, James Carlin, is going to be presenting the International Building Code. I have gone ahead and muted all attendees, so if you need to ask a question, please use the chat box or go ahead and raise your hand. There will also be a Q&A after the presentation, at which time we will also draw an attendee at random to receive their Amazon gift card. And we'll announce the winner this afternoon, along with a link to the video and a recording of the presentation. I'm going to go ahead and turn it over to James to get started. Thanks, everyone.
Good morning. Brad, do you have your hand raised? Let's see. I don't know if there's, is there anything in the chat from Brad, Kelsey, or?
I think it was direct to me, so I'll go ahead and address it.
Awesome, thanks. Good morning, everyone. My name is James Carlin. I'm the product manager for dampers here at Pottorff. Feel free to add any questions in the chat box or raise your hand while you're going through the presentation. A little bit about Pottorff as we get started. We've been in the industry since 1928, coming up almost on our 100-year mark. We've been doing this for quite a while. There's a lot in this presentation, so I won't spend a ton of time talking about Pottorff. This is an AIA accredited presentation, so we can give out credit for this. We can also perform this or give this webinar or presentation live for engineers throughout the country to get AIA or PDH credits. We just need to know who that is and what email address to send the credit to and how they want that sent out. We're going to go over the agenda for this presentation briefly. We'll talk a little bit about the code development process, damper ratings and actuation, whether they're fire dampers or smoke dampers, and then the bulk of the presentation will go through different fire barriers and the minimum requirements in Section 717 for protecting duct penetration of those barriers, whether it's a smoke-rated barrier, a fire-rated barrier, or maybe a combination of the two. So looking at the code adoption cycle, we have pretty much a 3-year adoption cycle. The code's been around since 1997, and this was a joining of different codes throughout the US. So the International Code Council came to uniformly present a building code to replace, say, the Southern Building Code, BOCA, or ICBO, to make sure that jurisdictions throughout the country can have a unified code that has all of the same requirements, all of the same exceptions, and I wouldn't say necessarily simplifies, but gives one place where the code is that engineers across the country can use for developing their building designs and maintaining certain layers of fire protection, specifically, which we're going to talk about today. With that, we're in the 2024 version of the code. So with the 2024 version of the code, we'll have that up until the 2027 version of the code is adopted. So it's a 3-year cycle, and the code hearings for those actually happen a few years before. So the code hearings for 2027 will actually start in 2025. They're actually looking at proposals for that now. Then once those code changes are approved, they'll be able to publish a 2027 version of the code. The philosophy for that is actually a layered protection. So there's going to be a passive element and an active element. The passive element is typically you're going to be dampers or rated walls where the building design itself actually stops fire and smoke from spreading through the building. And then an active component would be either sprinklers to extinguish a fire or a smoke control system that can exhaust smoke out of the building or help control smoke spread with dampers and fans throughout the building. And that's really a layer protection of fire and smoke containment using multiple different technologies and multiple aspects to make sure if one potentially fails, there's something in place to protect both from loss of life and loss of property throughout that building. There have been a couple of changes that have been made that have been in the code cycle for quite some time. Most of the changes we're going to talk about have been in the code since 2015. Now, there have been some clarifications of some of these changes as things have gone through. One thing, the 2015 version of the code did put in language to require the need for a dynamic sealing and radiation damper if there's a dynamic system during the event of a fire. So basically, a dynamic system is a system where the fans will be running during a fire, whether they're intended to or not. This language in the International Building Code actually stemmed from a bit of a loophole in the mechanical code. So the International Building Code and the International Mechanical Code are both developed by the ICC, the International Code Council. And in that International Mechanical Code, there is a requirement that every air handler that supplies more than 2,000 CFM has to automatically be shut down in the event of a fire, or has to be part of a 909 smoke control system that references Chapter 909 of the Building Code, to be able to make sure that that building is protected and smoke is exhausted as needed or contained as needed, depending on the design of the building. Where there was a bit of a loophole are, say, multifamily housing units that use individual air handlers per apartment that supply less than 2,000 CFM. There's no code mandated shutdown for those, so there is the potential for those air handlers to remain on during the event of a fire. Because of that, the codes dictated that any sealing radiation damper that's going to be used in a dynamic system like that needs to be dynamically rated. Now, for a long time, there was no way, even when that code change was put in place, to be able to certify a dynamically rated sealing radiation damper. And honestly, today, there's still no clear-cut way with, say, UL Underwriters Laboratories, who certify most of these life safety dampers, to rate a damper dynamically. We're actually working with AMCA, the Air Movement Control Association is actually working with UL to change those standards to put language in to uniformly test dynamically rated sealing radiation dampers. What UL is also planning to do with that is to not only certify dynamically rated sealing radiation dampers, but to certify floor ceiling assemblies as dynamically rated or statically rated. Right now, the majority of floor ceiling assemblies in the UL fire resistance directory are statically rated. So they've never been evaluated to have the fans on during that fire. UL stance right now is all of those assemblies would have to be fire tested with a fan running to get a dynamic rating. That would also apply to the damper. So you can't test the damper separately for a dynamic certification at this point. You have to develop an entire floor ceiling assembly. The only floor ceiling assemblies that I know of that are dynamically rated are wood truss, which aligns with most of your multifamily construction that will see this need for these air handlers that don't automatically shut down, creating a dynamic system. But the big problem there is they're all required to have fully steel duct in the floor ceiling assembly. Most floor ceiling assemblies use flex duct. It's much cheaper. And that addition of fully steel duct throughout the assembly, throughout the building complex, or throughout the entire apartment complex would add a massive amount of cost. And as soon as any engineer, contractor, building owner is going to see that cost, they're going to pivot to switch to a way to create a static system to be able to utilize that flex duct. So in order to do that, there's no clear-cut way in the code to shut the fans down. There's nothing in the mechanical code now for air handlers that supply more than 2,000 CFM other than requiring smoke detectors on common returns. So that is one option. There are other options to create a static system as well to shut down the fire. There's nothing specifically in the code for these air handlers that forces them to shut down a certain way. So right now, it's up to the jurisdiction to either allow a thermostat or something that'll see heat, like a fire damper, that'll shut the system down, or a fire smoke damper, or you can put a smoke detector in place to be able to shut that down under detection of smoke. That's not something that building code will probably change anytime soon. One thing to note when you're dealing with sealing radiation dampers, this became a huge issue with code officials and authorities inspecting buildings, especially when they're dealing with bathroom ventilation fans. Where this came into play is they weren't sure if these fans would continue to run, and some authorities having jurisdiction were requiring that additional smoke detectors were tied into these bathroom ventilation fans to make sure that they shut down during the event of a fire. Now, even before this change, UL had certain fan assemblies tied with dampers that were approved for these static assemblies, these wood truss assemblies being used. With those approvals, UL has reviewed the damper and fan combination and make sure it will not create a static system. UL recently changed their marking guide to fully dictate that. For a long time, bathroom fan ventilation manufacturers would have to write letters to explain this to code officials. There's also some problematic code that was added that would close a ceiling radiation damper under detection of smoke to address these issues, to turn off these bathroom ventilation fans. That section of the code is actually being removed for the 27 version of the code because it really used the smoke damper actuation language incorrectly, as ceiling radiation dampers don't have motors, and we'll talk a little bit about that in a second. But for the simple thing is, if you've got a bathroom fan that has a damper approved with it and it's listed in a floor ceiling assembly, that product will not create a dynamic system. UL changed their marking guide to fit that. The only thing that may be open to, say, design engineers and contractors is making sure the air handler that's supplying the unit shuts off, as if they're using a static assembly and a static damper, which is much more cost effective, they may need to shut that system down, whether with a smoke detector or some type of thermostat. Another addition in the 2015 version of the code that still confuses some regions is the language addition of corridor type dampers. And these are really tunnel type corridors, and I've got some slides explaining that. So when we get to the corridor section of this presentation, I'll go over that in more detail, as it may have some details that architects may use incorrectly that may cause problems when you're going through your final certification and inspection to get your certificate of occupancy. When you're talking about fire damper actuation, or kind of what I was talking about with shutting those air handlers down, there's typically two buckets for fire damper actuation. And most of the time, fire dampers use a fusible link to shut down. So it's just a bimetallic strip that separates and allows a damper to close either under spring power, under actuator power, or under gravity, depending on the damper design. Now, for these dampers, they can be used in smoke control systems. Typically, dampers that are used in smoke control systems will be dynamically rated. So a lot of times you'll be using a fire smoke damper in those applications that'll be actuated, and your fire smoke dampers actually have not a fusible link, but a thermostat that cuts power to the actuator and closes the damper under that application. So because of that, we typically recommend any damper that's in a smoke control system to be an actuated fire smoke damper. We definitely recommend having that actuator set point, that temperature limit set point to the limit of the smoke control system. Where this comes into play is the minimum certification for your fire dampers or your fire smoke dampers. Now, for a long time, all building code required dampers to be shut down within 50 degrees of ambient temperature. So that's typically 165 degrees. So if you're dealing with a system that is not part of a smoke control system, does not have a smoke control system, the fans will shut down, or there's some other type of passive smoke control. Basically, you're going to set your damper to close at 165 degrees or potentially 212 degrees if you're near a heat source where you're seeing ambient temperatures higher. So that's pretty much for most dampers, whether they're fusible link spring-loaded dampers or electronically controlled fire smoke dampers or something with an actuator. Now, any other dampers that are in the smoke control system are allowed to be set at a closure point that matches that smoke control system. Now, there was a requirement 30 years ago that you had to close all dampers within 50 degrees of ambient. So to get around that, manufacturers developed a dual temperature resettable link. And with that dual temperature resettable link, they had a low temperature and a high temperature that allowed the damper to be reopened after that closure point. Code changed to remove this requirement quite a long time ago. It's definitely something that's always been available in the ICC, certainly in the 21st century. But I do see a lot of engineering specifications that still require a dual temperature resettable link. This adds cost and complexity to the system and really isn't needed anymore. I also recommend specifying the damper to 250 or 350 to match the temperature certification of that smoke control system. And the same thing goes into effect really for all fire dampers or fire smoke dampers. The reason I say that is there's a cost savings to be had if your system is only designed to operate at 250 degrees. With that system, if the damper will never see 350 degrees, but you certify that damper to 350 degrees, you actually have to test to make sure that damper will operate at a higher temperature. And that equates to typically a higher operating cost and a higher torque cost for the motors for these dampers. Any of these dampers are going to that have an actuator are going to have a torque requirement to operate, but they're set to operate and tested at ambient and then temperatures added, like you would see if a fire affected a building. So as the testing goes, you start with a damper at say 2000 CFM, your minimum velocity, and then for a damper rated at 350, you heat that air to make sure that damper operates at 350. Now with that constant CFM volume to get that 2000 feet per minute in the static duct size, you are actually increasing the overall relative velocity that that damper sees. So there's much added torque to certify a damper at 350 than at 250. That's why if your system isn't going to operate at that, I definitely recommend specifying the damper close at 250. So something that engineers I recommend link to the rating of the smoke control damper. Now, of course, if your smoke control system is rated to 350, you've got fans that'll work up to 350 continuously, everything's set up for that, then by all means certify the damper at 350. There are options available for that, but there is an added cost risk when you're dealing with that. I also recommend engineers not to specify a damper rating at 350 if it's not used in a smoke control system. It's going to close at 160 or 212 typically well below 250. So there's really no added benefit to have a damper rated for 350 as it will never operate at those elevated temperatures. As far as smoke damper actuation goes, there's a few different allowances in Chapter 9. And really, what I recommend is what's cheapest for the building owner. Now, if you're dealing with a tenant improvement project that doesn't have a unified smoke control system or a building-wide smoke control system, or you're not in a corridor where you can utilize other types of smoke detectors in the building, by all means, you can certainly have the smoke detector supplied with the damper. The one caveat to that is there's really no damper manufacturer that offers an enunciated smoke detector because we really aren't going to know, and typically the mechanical contractors aren't going to know what system is going to be put in place. So most of the time I recommend the smoke detectors to be supplied by the controls contractor if they need to be enunciated or it's part of that smoke control system. Now, for tenant improvement, where there is nothing, you can certainly have those smoke detectors supplied with the damper. They don't have to be mounted with the damper. They can actually be mounted within 5 feet of a ducted damper or an unducted damper. And they really don't need to be installed on the damper coming from the factory. Now, that is a little bit of a labor savings, but there has to be clearance for these detectors and for the electronic connections, excuse me, that are going to be tying into the actuator and the temperature responsive devices for these dampers. Those connections do take up space on the sleeve. And typically when you're dealing with tenant improvement, there's not a lot of clearance to be able to install a damper to bring a building up to a newer version of building code. Because of that, I typically recommend to have the smoke detectors mounted loose. There's a couple of benefits to that. Not only does it give the installer a little bit of leeway in how they're installing the product, there are electrical wiring diagrams and instructions on how to mount that from the manufacturer as well. And typically, if these are externally mounted to the sleeve, you can then have both the smoke detector and the actuator on the same size, which is not common, is not available for all damper sizes, and may not even be common for most applications. So having them shipped loose does give one other added benefit. You are able to return them a lot easier if they are not needed, or if they're going to be supplied by a controls contractor down the road. Whereas if they're damper mounted, it's not as easy to return those types of actuators because of unusability in future projects. This is going to be the bulk of the presentation. So this is an overview of all of the different sections of section 717. We go through the different assembly type. And then when you see that assembly type, there's a number in parentheses. That's actually the section that calls out the requirements for that type of assembly. So whether it's a fire barrier in section 707 or a corridor in chapter 10, section 1020, that'll link you back to where the minimum requirements for that assembly are. There's a typical rating, so it's 3 hours, 2 hours, or 1 hour, and there's a function, and then required minimum protection or recommended protection that we have as we go through these different assemblies. So this is really just a cheat sheet. You don't have to memorize this. It's something that we can send out as a bit of a cheat sheet after the fact as well. Getting into the bulk of the presentation, I'm going to talk a little bit about different fire barriers, firewalls, protective devices, going from most restrictive down to least restrictive. And then we'll talk about some different things at the end, like through penetrations are going from one story to another. When we're talking about penetrating firewalls, it's not very common, but the code does require any firewall penetration to have a fire damper protecting it. There really aren't any exceptions. Most of the applications I've seen where this comes into play happens when there's, say, a building owner that takes over multiple occupancies that are sharing a firewall, but doesn't necessarily change the address for those occupancies. So those occupancies may have multiple addresses and a firewall bisecting them, but the building owner may want to upgrade the HVAC system to be able to utilize airflow across that fire barrier. I have seen in cases where instead of putting in a fire damper in that application, the owner changes the certification or changes the address with the jurisdiction and it becomes all one occupancy. It's very rare to see firewall penetrations, but if you do, you do have to protect these with a fire damper. Now, these firewalls are different than, say, your exterior wall mounts. We'll talk about exterior walls in a little bit, but these firewalls actually have to be 3-hour rated and structurally independent, so they won't collapse in the event of a fire. So with that, they typically have to have a 3-hour rated damper. With that, you do have to have that protection, but it's very uncommon and a bit different than the exterior wall that I'll talk about. When you're dealing with a fire barrier, you're going to be dealing with barriers that are typically 2-hour rated. And most of the barriers we're going to be talking about from here on out are going to be rated for less than 3 hours. So there's one thing I do like to bring up with the hourly ratings of barriers versus dampers, and that's code mandates that any barrier that's rated for 3 hours or more be protected by a minimum of a 3-hour rated damper. And then any barrier that's rated for less than 3 hours can be protected by a damper rated for an hour and a half. This actually can be a bit confusing to some folks because it seems counterintuitive to have a 2-hour rated barrier protected by an hour and a half rated damper, but that's been in the code for quite some time. I don't know the history for that, but it is certainly something that can confuse some folks. Now, using an hour and a half rated damper will also reduce your cost. So it's definitely something that I recommend for your 2-hour or 1-hour rated barriers. Now, what we'll also start talking about with this presentation is different exceptions for removing the need for, say, fire dampers or smoke dampers, and where that is throughout the code, why it's risky, and what we recommend. Now, a lot of these exceptions are going to be common across multiple barriers. If it is an exception for one, it may apply to multiple barriers. I'm not going to go over them at each different barrier. I may reiterate some differences between different barriers and some additional requirements, say for shaft walls, but for the most part, A lot of these exceptions are going to be common throughout this presentation. One such exception is that ASTM E119 without a fire damper. So if you're able to test a fire barrier that has a hole in it for a duct and there's no fire damper in there, there could be some other type of protection. There could be some other type of device that's actually stopping fire from spreading to one side of the barrier to the other. Then by all means, you can remove the fire damper requirement in that fire barrier. That's typically not common. There going to be some other development options available, but typically this is something to be able to run a fire test. If you can run a fire test with an opening that fire won't get through with some device, by all means, remove the fire damper. But for all intents and purposes, you're going to need at least a fire damper requirement for these. Now, if your fire damper will interfere with the 909 smoke control system, by all means, it's very valid to remove that damper. You don't want a damper that's not tied in with the smoke control system to shut down and stop a building from, say, being able to exhaust smoke during the event of a fire. The only thing is most of the barriers where you're using these fire dampers are going to have a smoke requirement as well for a lot of times. And with that smoke requirement, you're going to have the cost of a damper with an actuator no matter what you do. So removing the fire damper doesn't really add much cost savings. And it could potentially be a detriment to the system because even though you have a smoke control system in place, if you're seeing elevated temperatures of 250 or 350 degrees, typically that barrier is very close to a heat source. So adding the fire damper protection or thermostat that shuts down that damper will in fact help protect that fire barrier from withstanding that 2 hours. And at that point, if the damper is still being needed to be used for smoke exhaust, there could be a potential for the barrier to degrade without that damper closing and that smoke to spread through that ductwork. So we think it's a little bit risky to remove both of it, especially if it's a smoke rated barrier in addition to a fire rated barrier. There's little cost savings to be had, and you're at the upper end of, an area in the building that hopefully the occupants have already left, and you're really just helping to protect the structure of the building at that point, maybe helping to protect firefighters from extinguishing that barrier. So we think having both a fire smoke damper for those applications where it's not tied into the 909 mechanical smoke control system is valid. But for the most part, these are going to be active parts of that system, and they're going to help work until it's absolutely critical to protect that barrier. Now, one exception that's used quite a bit is if you've got a fully sprinklered building, so you're putting out that fire, the fire is not spreading, and you've got a barrier rated for less than or equal to 1 hour, and it's fully ducted. Now that seems to be a reasonable exception, but it can be a bit risky when you're talking about a building with multiple stories that has the potential for the duct, that 26 gauge duct, to be dislodged. The rationale here is a 26 gauge duct is going to stop any fire from spreading through that barrier from one room to another or across that barrier. And that is the case if the duct remains intact and the smoke or the fire is actually put out very quickly with that sprinkler system. Now, if there's a failure of that sprinkler system where you don't get to that damper or that fire put out and you get to a penetration that may have had a damper, there could be the potential for that duct to degrade. Certainly the rated barrier may degrade if it's using gypsum as its main protection, which is very common for 1 and 2 hour rated walls. And there is the potential for a duct breach. So if you've got multiple stories and there's a fire on a story above, that duct could potentially get dislodged by something falling during the fire, and there will be an open penetration at that point. Now, your fire damper is certified to protect against that. Fire dampers are forced or required to go through a duct drop test where you install that damper, you actually take a 55-gallon drum with 400 pounds of sand, and you drop it on the duct and make sure the duct can shear away with the improved breakaway connection, and the damper stays in place, protecting that fire-rated barrier. That's why we think it's a little bit risky when you're dealing with fully ducted applications, especially if they're 2 hour rated. Now, if it's 1 hour rated, there are some applications where it is still risky, but it's less risky than, say, this application, typically when you're dealing with corridors where there's penetrations that don't actually service that corridor. But there is always a bit of a risk for that duct to be dislodged. if it doesn't have a damper protecting that barrier, regardless of the hourly rating of that barrier. Now, horizontal exits are a bit different. They're actually not exit enclosures. They are meant to be an area of refuge. So you're not actually using a horizontal exit to get out of the building. You're using a horizontal exit as an area that has a minimum of 2 hours of rated protection where you will be safe until first responders, firefighters can come in, they can put out that fire or help you evacuate the building. One common application for this I see is in multi-story hotels. You may notice on the diagram, the floor plan, or the evacuation plan for that hotel, though there may be some exits that are your closest point of egress. Now, some other exits may actually have some additional indication. So it may have a handicap symbol on that. And that handicap symbol is actually meant to designate a horizontal exit. So if there's someone that can't get up and down the stairs under their own power, they can go to that exit enclosure, that horizontal exit, um, and they'll have an area where they'll be safe for up to 2 hours. Now, any duct penetration for this, which is typically uncommon, would have to have a fire smoke damper because you want to make sure there's no fire that gets in, and more critically, you want to make sure there's no smoke that gets in that gives the occupants at least 2 hours of protection. Typically, that's not needed. A lot of times, firefighters are able to help get people out, but this is a designated safe area that's a shelter in place type situation. And it's very rare that there are duct penetrations for these types of applications. Getting into shaft enclosures are actually the easiest way for fire and smoke to spread through a building because fire and smoke has a natural tendency to travel upwards throughout the building. And smoke can actually be pumped downwards if fans don't shut off in the event of a fire and you're dealing with a supply shaft. So these are going to have most the significant amount of requirements, but shafts have also been in the code for quite some time. So there are also a significant amount of exceptions that have been grandfathered into these shafts. We're not going to talk about the ASTM and E119 trade-off again. One thing we will talk about is some of the differences when using what's called a 22-inch subduct. So this is something that's specific to shafts. And if you've got a 22-inch subduct where you have either an exhaust shaft or a supply shaft, and that typically it's used for exhaust shafts, but if you've got an exhaust shaft where that subduct is actually turned up and extends 22 inches up into the exhaust shaft, you can, and it has continuous airflow to the outside, you can remove the damper from that shaft wall. That's typically the only way to use that subduct is your exhaust shafts. Now, when you're dealing with these exhaust shafts, there is a requirement for the fire damper that you can remove and the smoke damper. And you can certainly do that, but the requirements are a bit different. To remove the fire damper, it just has to have that subduct, and that's been in code for quite a long time. To remove the smoke damper from the shaft enclosure, it has to be fully sprinklered. Typically, it has to be used with a toilet or bathroom exhaust, and there has to be continuous upward airflow to the outside of the building with standby power. Now that makes sense. If you've got standby power to the fan and that fan is continuously running, and your fan is actually rated a high temperature rating for that smoke exhaust system, you're good. That's how smoke exhaust systems work. So that's a valid trade-off. And removing the smoke damper in those applications certainly makes sense. Now you do want to use a high temperature fan, so you want to make sure that fan is continuously exhausting. The reason that's a concern is due to what called reverse stack effect. Now, for a long time, I thought reverse stack effect was one of those theoretical things that could potentially happen. You could have very cool smoke, very hot smoke that goes into a cool shaft that actually gets pulled down the shaft if you don't have continuous ventilation. Now, I thought that was, if that did happen, the smoke would not continue much further down the building to actually cause somewhat of an issue. It may just stay inside that shaft. Now, what I learned during one of the code revision cycles is in places like Arizona, where there's a very big differential temperature between the conditioned air and, say, the outside air, you may actually get a much more common reverse stack effect where your shafts actually have a pretty cool temperature to cool down the building. And if there is a failure, say an electrical failure without the standby power or a fan failure, you may actually get that smoke to cool and affect areas down below that where the smoke won't naturally ventilate out of the building. There was a code official that was a fire marshal that was in a fire where it was kept to one story, so it didn't actually spread through multiple stories, but there was a failure in the sprinkler system, and there was no backup power generation for the exhaust shaft. So the fire was contained in one story, but they actually had smoke damage on the story below the event of a fire. They had used that subduct as an exception, and the smoke actually cooled and was pulled down that shaft. So if you don't have constant airflow or high temperature fans that are pulling that smoke out of the system, it is a bit risky to remove your smoke damper because that smoke will get in the shaft and it could be pulled down to a non-affected area. Now, if you've got a parking garage that's separated from a building with more than 2 hour rated construction, you can certainly remove the damper requirement for that. Most of your above ground parking garages that you see are going to be naturally ventilated. Where this can be a bit risky is when you're dealing with subterranean parking garages that do have to have ventilation, because there is the potential for a high fuel load that is between your occupants and any means of egress. If you've got people below the fire and they have to get past that fire, it could be a dangerous situation where they actually have to move past that fire, past the smoke, to be able to get out of that subterranean parking garage if there is a fire. We're also seeing an increase in fuel load for these. If it is sprinklered and it is protected, that is certainly a good layer of protection. But what we're seeing with, say, electrical car fires these days is there's a huge increase in the amount of water that's needed to extinguish that fire. And because of that, it can be a bit risky with these higher fuel loads in these subterranean parking garages. So it may make sense to keep those dampers in those shafts that are supplying air or exhausting air out of that smoke garage, out of the garage system. Now, if you're dealing with anything that has a fuel source, so any duct that's for kitchen or clothes dryer exhaust systems, we definitely recommend removing the fire smoke damper for those applications. Any damper that's in that barrier is going to create a point of ignition, whether it's a grease buildup or lint buildup, that's going to create fire in the duct, and it's going to cause way more problems than the damper can protect against. So we definitely recommend removing those for those kitchen and clothes dryer exhaust, or say if you've got bathroom exhaust ventilation. Now that is the smoke damper and the fire damper exception. There are some additional exceptions that tie into this down through the rest of this presentation. Now, for fire partitions, you're probably going to see these mostly in corridor walls. They were used in covered malls, but those aren't really being built much nowadays. You may see them in elevator lobby separations as well. So some of the exceptions are valid, but are not commonly used. But there is a lesson to be learned with that exception. If you have a fire partition that doesn't extend from deck to deck, so it doesn't extend the wall stops at, say, a non-rated ceiling, or doesn't go all the way to the floor above, then there really isn't a lot of protection that can be made with a damper in that wall penetration. And certainly for these multi-tenant penetrations that didn't extend from the floor to the roof above, you could remove the fire damper. It's certainly valid. Pretty much any damper in a non-rated construction will not supply you with the needed level of protection. Typically, the fire is going to find a way around that non-rated construction and get past that damper. So it's really adding cost without any additional protection. There are some different exceptions here for these fire partitions, specifically when you're dealing with what's called a subduct. Now, the subduct has to be 26 gauge, it has to be relatively small, so 100 square inches or less, and it has to have 16 gauge sleeve with 16 gauge angles, and it has to be protected with mineral wool around the angular space between the subduct and that smaller duct inside. This doesn't really make sense financially. Your damper is going to come with mounting angles that may, for this size, very often be less than 16 gauge. Also, it's really not that much cheaper to install this compared to a traditional curtain style fire damper. That fully sprinklered exception does come up again for the fire partitions as well as the fire barriers. It's pretty much the same risk that I had mentioned before, so I won't go through that again. Now, getting into corridors as a damper manufacturer, we kind of lump these into three different types of categories. It has to do with the rated ceiling for those corridors. So these corridors are going to have a rated wall typically for all their applications. But there are a lot of corridors that do not have a rated ceiling. So there's really no requirement to protect the rated ceiling. It's just a finished ceiling that has no rating. And for the most part, you're going to have a fire smoke damper that's protecting that corridor. There's going to be a smoke requirement, and it'll be a separate requirement to remove that smoke damper compared to that fire damper. So we typically recommend fire smoke dampers for these applications. Now, you can remove the fire damper portion if it's a fully sprinklered building and the duct is protected with fire stop caulk per 714, section 714. We think that's a bit risky as there is the potential for some degradation through that system. And as far as I know, per section 714, the fire stop caulk doesn't necessarily need to be certified with through a hose stream test that a fire damper would. So if you just have the fire stop caulk protecting that penetration, there could be the potential for firefighters to dislodge that in larger openings. Because of that, we definitely don't recommend it. There's also the potential for duct breach due to debris. Now, if you've got a building equipped with the 909 smoke control system, it is very unlikely that a smoke damper installed in the corridor will not be connected to that system. So there's really no exception there. The exception I see used the most is if you've got 26 gauge ducts with a system that has no opening serving a corridor. I see this used quite a bit. It is a bit risky due to that duct breach due to falling debris, but I do see engineers use this quite a bit to potentially reduce the number of fire smoke dampers throughout the building. So it is an exception that's used quite a bit throughout the industry. It is a little bit risky, but it is something that is widely used. Now, if that 26 gauge duct system has no opening serving the corridor, basically your smoke compartment resides within that corridor and you don't have any breaches of that smoke compartment. So there's less of a risk of smoke for the damper to be in that place. We think it's a little bit risky when you're dealing with corridors specifically, because corridors are a means of egress out of the building. So we think it's best to protect that as best as possible with your fire smoke damper. But if it is going to interfere with that smoke control system, you can certainly remove it there. And I've certainly seen many engineers remove that damper if there are no openings serving that corridor. Now, the next type of corridor has a rated ceiling. So any rated ceiling needs to be protected. That's throughout building code, whether it's a corridor ceiling or any other rated ceiling and any other floor ceiling assembly. With that, you do have to have some type of ceiling radiation damper protecting those openings. There are some ceiling radiation dampers that are certified as smoke dampers as well. They're typically only for T-bar type ceilings, so we don't recommend using those for most applications. For most applications, we recommend using a ceiling radiation damper in the rated floor ceiling, and then using your fire smoke damper in the sidewall penetrations. Now, the sidewall penetrations are exactly the same for whether you have a rated ceiling or not. So typically, I won't go through those again. But then if you do have a rated ceiling, you do have to have that ceiling membrane protection. So you have to have that ceiling radiation damper for those applications. I talked a little bit about in the beginning of the presentation about tunnel type corridors. Excuse me. Those tunnel type corridors use a portion of the continuity section of the code to be able to extend the continuity of the wall to a non-load bearing ceiling. This is very important because you have to use the same stud construction of the wall or the same concrete construction of the wall for the ceiling. Typically, this is going to be stud construction because corridor walls and corridor ceilings for tunnel type applications are typically rated for only 1 hour. Now, there are very specific fire smoke dampers that are certified as corridor dampers. They go through an additional 1 hour test to be installed in this tunnel type corridor type ceiling. The pitfall that I'd like to point out for this is there are framing instructions for horizontal applications when you're dealing with these tunnel type corridors. Now, these are really only applicable to these tunnel type corridors. So you have to support that corridor ceiling from the bottom on both sides with the identical wall construction, and it has to form a continuous barrier up to the ceiling over to the side. Because of that, it's really for these specific applications. They're widely used in California. They aren't really used throughout the nation, but it could pose a potential risk to architects that see this horizontal framing detail and call that out in non-tunnel type corridor applications. There's really not a lot you can do for these other applications that are not these non-load bearing tunnel type corridor applications. I'm going to get into what you can do to protect a floor opening or a through penetration when you're installing a damper horizontally in a little bit, but I'm going to talk about smoke barriers first. Now, smoke barriers are commonly 1 hour rated. So with the smoke barrier being commonly 1 hour rated, a lot of times they're fire partitions as well. So they have that similar requirements. And they have to maintain the requirements of both. So there's a fire rating that has to be there for that requires a fire smoke damper, and there's a smoke rating as well. Now, there are a couple of exceptions for removing the smoke damper in these smoke barriers. Typically, if you've got steel ducts with openings limited to a single smoke compartment, that's also the rationale behind the removal of the corridor exception, where there's no steel duct that's not servicing that corridor. If you've got a single smoke compartment, you really don't need smoke dampers to protect against the spread of smoke from one smoke compartment to the other. If there's smoke in one area of the smoke compartment, it's not going to get recirculated to any extent that's going to cause a loss of life or anything to that effect. Typically, the alarms are going to go off and people need to get out of that smoke compartment. For the most part, this is very reasonable. Now, what happened in 2012 is for Group I2 Condition 2 occupancies, the allowable smoke compartment was greatly expanded. And as long as you had a fast response sprinkler system, through the building where there's going to be the fire put out very quickly, you could remove the smoke damper requirements through a lot of these occupancies, through a lot of barriers in these occupancies. What this turned into is a very large smoke compartment that was actually bisected by fire rated barriers in there. So these 1 hour rated barriers and corridor walls or carriage suites still needed a fire damper to be protecting them. Now, with that fire damper, you would have to have some type of control a lot of times to be able to tie into a smoke control system, or you have a fire damper that now has a fusible link where you don't know if it's going to be open or closed, and you don't know will interfere with the smoke control system. So rather than removing that fire damper requirement and then potentially leaving a rated barrier unprotected, we typically recommend putting in a fire smoke damper, as they will both be tied into it. There's a fire rating for that and a smoke rating. We think this is incredibly risky due to the overall size of the smoke compartment. It's, I believe, 60,000 square feet, which could be the entire occupancy. And it's really relying on the sprinkler systems to work and potentially your fans exhausting smoke out of the affected area. So if any of those systems fails, you're going to have the potential for smoke to spread, because even though your sprinkler systems are critical and they're putting out the fire, they're not stopping the smoke from spreading. They're actually creating a source of smoke. So you could have the potential where there's smoke that needs to get much more smoke that needs to get exhausted. It's also relying on the hospital staff to be able to get patients out that may not be under their own power. They may not be able to get themselves out before first responders get there. I think that's incredibly risky. We certainly know after recent events that their hospitals are a lot of times at 90% or over capacity, and there's a constant need for additional healthcare workers. They're spread pretty thin, so putting this on top of them to be able to get people out in emergency, we think is incredibly risky and not something we typically recommend. Now, if there are smoke
James,
partitions
we've
that
got a
are,
real quick question.
sure.
Shireen asked why it's called horizontal exit if it's not used to exit the building.
That's what the codes called it. It's kind of a legacy thing in the code. They've always called it a horizontal exit because there has to be an exit passageway, but not all the occupants can actually exit the area. So it was just always called an area of refuge. That's just one of those legacy things that have been in the code for 30 plus years. Getting into smoke partitions, there are some smoke partitions that are 0R rated. They're very uncommon. They could be in corridor and carriage through walls in certain elevator lobbies. Um, if you do have a smoke partition and you put in a smoke damper that will interfere with the 909 smoke control system, you certainly can remove it. It's just rare to have that. It's also rare to have a smoke partition that doesn't have an hourly rating, but they do exist. So you don't need a fire damper for this, and potentially you would need a smoke damper, but that would be rare. Now, exterior walls are a little bit different than firewalls, as they can be 1 or 2 hour rated. They can be 3 hour rated, but a lot of times they're 1 or 2 hour rated. And they have a calculation that sets the minimum amount of protected openings and what that minimum is. If you pass that threshold, you have to protect the openings with something. It can be a fire damper, it can be fire rated glazing, it can be a fire door. A lot of times this takes into account the occupancy type and more often the how close that exterior wall is to the lot line and how much of a risk there is if that building is on fire from spreading to another area. So if you're in an urban environment, it may be, if that exterior wall is within 10 or 15 feet of another occupancy, you have to protect that exterior wall. So you may need to use a fire damper, and there's not going to be exceptions there, but you don't specifically need to use a fire damper if you've got an occupancy that's further away and has a different minimum amount of protected area. This does introduce some issues in places like New York or Miami where these exterior walls may need some requirement protection, and there may be additional protection for louvers and things. That's typically when I recommend contacting us for support because you may have multiple certifications that you have to balance in the same installation. Now, I talked about horizontally mounted corridor dampers in corridor ceilings. Now, if you've got a through penetration where you're going for duct penetration is going from one floor to another, typically you're going to have to put a shaft in place unless you can install a damper in that floor that protects that floor opening. All dampers mounted in floors have to be in concrete no load bearing floors. That's really the only option. There's no load bearing option for a stud application. So if you've got a fire damper installed in a horizontal stud floor or wood or metal stud floor, I do recommend contacting, say, a damper manufacturer or someone to get some clarity on that because there could be some issues with that. A regular fire damper wouldn't be able to be installed in that. So there's some things that I recommend. There may be some options available where you separate that that load bearing floor assembly, but for the most part, you're going to have to put a damper in that. Now, the biggest exception I see used that's a valid trade-off is if you've got bathroom exhaust, typically where you're protecting the ceiling membrane. It's a small diameter duct and it only opens to a single dwelling. You can certainly penetrate that, and it's 26 gauge duct, so it's fully ducted, and it's 3 floors less. You can certainly use that without a shaft enclosure. You don't need that shaft enclosure for those. I see this used quite commonly for bathroom exhaust in hotels and things like that. It's a very valid trade-off. And when you're protecting that ceiling membrane, there's very little risk with smoke and fire from circulating through that building without the need for a shaft to protect that. Now, for a ceiling membrane penetration, for the most part, you're using a ceiling damper, and you're going to have to use something like that. Now, if there is no ceiling damper you can put in a shaft enclosure, but that's going to get very costly. Now, it may be the only option for through penetration, but you can certainly use a shaft if you want to for that type of application, though it is quite rare. Most of the time, you're dealing with a ceiling radiation damper, or you're dealing with some other type of assembly. That's it, and we're right at the end of the hour. I will stick around for questions. If there's anything in the chat, anybody wants to raise their hand, I can certainly answer any questions available. Thank you all for coming. Appreciate your time today. If you do have other appointments or need to leave, I certainly understand. You can certainly contact us at any time after this to answer any questions as well. So I'll open it up for questions now.
James David asks, does it need to be a 3-hour damper in the floor?
It depends on the rating for the floor. If the floor is a 3-hour barrier, then or say a 3 or 4 hour barrier, then it would have to be a 3-hour damper. If the floor is a 2-hour or a 1-hour rated floor, then you may not have to do that. Now, for most applications, your concrete floor is probably rated for 3 hours, so it may need that, but it depends on the hourly rating of that floor.
Mark says, when the code says fully ducted, does that mean both the supply and return from the unit, or can it just be the supply with RA plenum?
There are some allowances for, typically it's going to be the supply and return, but there is an allowance to use flex duct to the air handler or the diffuser or grill or something like that. So it may not necessarily be an option for an RA plenum. A lot of times there has to be some extension of duct past the fire rated barrier to make sure that's protected as well. So it may not have to be fully ducted, 26-stage duct all the way through, but it definitely there are some allowances for using flex duct to the end user device with a certain amount of duct extended through that rated barrier, whether it's the return plenum or not. So it's a little bit different, and there's some clarification that gets a little bit questionable. So if you do have a specific application, we can look at it, and I can point you to those sections where they show the flex duct connecting to the air handler device.
And Walter, I'll answer your question. So when are we having another webinar? We don't have another date just yet, but we are planning our next webinar for 2026.
We can also offer this webinar for specific customers if they want to set something up, or for specific engineering groups. We give this webinar quite a bit during the year. So feel free to contact us, contact your regional sales manager, and we can set up presentations for credit or for something specific. One thing I can note as well, for anybody that needs credit on the calls, we have some courses online at our website that you can take. It's kind of like a defensive driving type course where you can go through and answer some questions, and you can get PDH credit for that as well. So if you're running into an issue where you need to get PDH credits towards the end of the year, you can certainly use that as a resource.
Alrighty, well, feel free to stick around and ask some more questions. You can also always contact us after the webinar, and we will be sending our attendees the video recording and the slides of the presentation. We'll also try to get those uploaded on RepConnect for you all. And you can always share our webinars on our YouTube channel, which that should be uploaded later today. So yeah, keep an eye out for that 2026 webinar announcement. And thanks everyone for joining us today. And James, thank you for such a great presentation. Okay, Shelby, I was able to get an answer on that. It looks like we are able to offer credit, and we'll be able to go ahead and send out certificates. Thank you again for asking. James, we have a question on how a dynamic damper works.
Sure. So basically a dynamic damper could be a spring-loaded fire damper or a smoke damper or a fire smoke damper. The three different dampers kind of work a little bit differently. So your curtain style or your multi-blade dynamic damper that doesn't have an actuator or a motor will have a spring. It'll be spring-loaded, and it'll have a fusible link, and that fusible link is just two pieces of metal with solder that heats up, separates, and allows the blades to close. Your smoke damper is going to have an actuator, and it's going to be tied to a smoke detector, where if there is a smoke detector, so a signal from the building alarm, that'll close upon that signal with the loss of power to the actuator. And a fire smoke damper can do either. So a fire smoke damper has an actuator and a temperature responsive device, typically not a fusible link. Most commonly, fire smoke dampers have a thermostat. So it's a bimetallic disc that sees a certain temperature, cuts power to the actuator if there's a fire localized to that thermostat, and closes the damper blades. It'll also be tied into a smoke detector or a building fire alarm system or building management system, where if there is a smoke detector tied into that damper, or if there is a system-wide smoke detection system, power will be cut to that damper and the actuator will close that damper. They both get tested a little bit differently, whether it's an actuator or not. But for the most part, there's going to be, for a fire damper, there's going to be something that sees an elevated temperature and the damper closes, or if there's a smoke rating, whether it's a fire, smoke, or smoke damper, there's a detection of smoke and that damper will close.
Alrighty, it is 10 after the hour. If no one else has any more questions, we'll go ahead and log off. And if you do end up with some more questions, feel free to contact us afterwards. Thank you so much for attending, everyone.